In this video, I will be talking about the convergence of sequence of real numbers. So what do you mean by convergence? So, so sequence of real numbers is written as Fn. Okay, sequences of real numbers is written as Fn, and suppose there is just a real number L. Then we say that Fn converges to L. This means tends to. Okay, we read it as tends to or converges to. So Fn converges to L as n tends to infinity, or limit n tends to infinity of Fn is equal to L when, if given any epsilon greater than 0, there exists a real number, natural number k, such that mod of Fn minus L is less than epsilon for all n greater than equal to k. Now this may look very complicated, but it is actually very easy. Let's look at this graphically. Suppose this is a sequence, okay, and suppose this is a and this is our limit. Then you may see that, let's take epsilon is equal to 0.1, then and let's name it as x, then x minus epsilon and x plus epsilon. We have a band like this, and you see that after this point, let's name it k, after this point the sequence is bounded between this band, okay, x minus epsilon and x plus epsilon and x minus epsilon. So for all n greater than equal to k, we have what? We have the sequence that is Fn and the distance between Fn and x, or Fn and L, less than epsilon, and that's why we write Fn minus L less than epsilon. Okay, I hope this is clear. Let's look at one example. For example, 1 by n. This is this most simple example for sequences of function, and 1 by n converges to 0. How to show this? So let epsilon greater than 0 be given. We will always write this at first, and then we will reverse engineer the process. Okay, how do we do this? First consider 1 by n minus 0. We have to show that this is less than epsilon, so let's assume that it is less than epsilon, and then have the condition. So 1 by n minus 0, obviously it means 1 by n, mod of 1 by n less than epsilon, but 1 by n is positive, so we may discard the absolute value, so we may discard the modulus. Then we have 1 by n less than epsilon. But when this happens, 1 by n less than epsilon means for which n? We have n greater than 1 by epsilon, right? So let's take k is equal to 1 by epsilon, and then what? And then k is equal to 1 by epsilon, and n is equal and then 1 by n minus 0 is equal to 1 by n, and we have n less than equal to greater than equal to k, and greater than equal to k means what? 1 by n less than equal to 1 by k, right? So modulus of 1 by n is less than modulus of 1 by k. We can discard the absolute, we can discard the modulus as previously explained. So we have 1 by k, but k is greater than 1 by epsilon. Okay, So in this case 1 by k is less than epsilon. So we will write this like this. Let epsilon greater than 0 be given, then there exists natural number k with k equals to 1 by epsilon such that 1 by n minus 0 is less than epsilon for all n greater than equal to k. And this shows that limit n tends to infinity of 1 by n equals to 0. Okay, thank you.